We're good.
Okay, well, I'm going to go ahead and get started. And to begin, I'd like to say thank you to Pete for the coordinating of the webinars. We appreciate what he does as the Extension Range Unit. Okay, the topic that I've been asked to present on today is Rains and Pastoral, what I call application technology. Over the years of being an extension specialist, I've had lots of questions, lots of comments about how do I apply this herbicide? Why did that herbicide application not work? And a common trend that I kept seeing over and over was they applied it the wrong way. And typically with rains and pastoral, we are dealing with low input crops. So if you take a row crop field, be it cotton, soybean, something like that, those guys are miles ahead of us in how they apply their herbicide. For one, they're using a lot more expensive products. They are also spraying a lot more often. With rains and pest, we're not quite to that point yet because we're growing a lower input crop. And even though we like to complain about the cost of herbicides, in reality they're cheaper compared to lots of these row crop herbicides. So here's kind of an overview that we're going to go over today and what we're going to look at throughout this presentation. Calibration, we hear about it all the time. But lots of application errors and mishaps can be traced back to sprayer calibration. Distribution pattern. That's something else we got to keep in mind. We can have our spray rig calibrated, be putting out the correct amount of herbicide to the acre, but we could also have a bad distribution. Nozzles, we got to keep that in mind. The order at what you fill your sprayer, the mixing order, that makes a big difference. Surfactants, we hear all the time about we have to use a surfactant, but let's kind of look at that a little bit more throughout this presentation. Dyes, dyes help with coverage, coverage helps with kill. We got to get good coverage of that plant before we can get a good mortality on that plant. Then we got to leave in the safety gear. So to begin with, let's look a little bit at ground broadcast application. This is probably the application method that the majority of herbicide applications go out with, be it a small ATV broadcast sprayer or something large right there like this tractor and PTO driven spray rig. You know what we always say anytime you're going to broadcast spray is calibrate. Anybody with just minimal amount of plumbing knowledge, they can put a pressure gauge on their spray tank. If you know how to turn a wrench and wrap Teflon tape, there is no reason you do not have an idea of what your spray rig is putting out. It also hopes to have a pressure control. However, if you look at the order at what's up at these bullet points, you'll notice pressure gauge is above pressure control. If you're only going to do one or the other, at least do a gauge so you know what you're putting out. If we look at some advantages of some of the ground broadcast applications, there's a lot of areas in Texas that are relatively small prickly pear patches. If we go out and try to spray each prickly pear colony by individual plant treatment, typically we will exceed our maximum rate of herbicide per acre. However, if we were to go out and treat an area like that's in this pixel, let's say that's a 5 to 10 acre prickly pear patch, and we do a ground broadcast application, it's very practical, and we can also maintain the proper rate while we are spraying. So some general rules of thumb, typically be 20 to 30 psi, pounds per square inch. Also typically 10 to 30 GPA. Keep in mind, the lower the GPA, the more acres you can cover with that tank. The higher the GPA, the more coverage that you get. Here's an example that shows why calibration is extremely important. Let's say the recommended rate of the herbicide is 1 quart to the acre. So, here on the vertical axis, you have herbicide quarts per 100 gallons. Here you have spray volume gallons per acre. And you can see how, depending on how much we're putting out, what our spray volume is, that could greatly impact the herbicide rate that we are putting out. You know, some simple steps to go through if you're going to try to calibrate the tractor is, number one thing, if you have a boom type sprayer, determine the nozzle spacing or the swath width. Stake a course. If you have a boom sprayer, the nozzle spacing is extremely important. If you have a boomless sprayer, we will go by swath width. Stake a course. We're going to look at that more in depth there in a minute. And pick a gear and the RPM that you will be spraying in. Drive that course a few times. Typically, I tell people, or if I'm doing it myself, I will drive there, then I will drive back, and I will average those two together, and that'll be my time. Then what I'm going to do is I'm going to catch a nozzle, catch the output of one nozzle for the duration of the time that it took me to drive that course. If you have a boom type sprayer, the ounces that you catch will equal gallons per acre. So if you want to take a screenshot of this table right here, if you have an 18 to 20 inch nozzle spacing, your length of calibration course ought to be 227 to 204 feet. If you have a boomless sprayer, let's say you have a 35-foot swath width, your course will be 157 feet. Something else to keep in mind, boom sprayer, the ounces caught is gallons to the acre. On the boomless sprayer, we're going to catch a lot more liquid. The pints caught equal the gallons per acre. Another little calibration method that I've been known to use a few times that's extremely convenient, and it's one that you can do if you do not have a pressure gauge, pressure control and all. However, I would still recommend you get that. But somebody a lot smarter than myself put together this Excel spreadsheet. And what you do is you enter in these red numbers. You enter in the gallons per acre, the desired. So let's say we want to spray 20 gallons to the acre. You enter in how many gallons you dump in a tank. So let's say I dump a 5-gallon bucket in a tank. You spray that tank out and you time how long did it take me to empty those 5 gallons in minutes. So right there it was 1¼ minutes. So the black right there, that's no entry requirement. The boom width is 20 feet. So if you look down here in the blue, speed required, miles per hour. So if we drive 5 miles an hour, because nobody has a speedometer to get it 4.95 and hold it consistently, our application, our GPA, will be at 20 gallons to the acre. It's kind of convenient, very handy. If anybody would like this spreadsheet, my email address will be on one of the last slides. Please send me an email. Something else that I find is very impressive, and lots of people do not take the time to look at these, and lots of people don't really even know they exist, is every nozzle manufacturer makes a nozzle table. This right here is one of TJet's tables, but keep in mind that Greenleaf, Boombuster, everybody that makes a nozzle will make one of these tables. And if we zoom in and look up close at one of these tables, what you will see is this right here is the size of the droplets. M is for medium, orange is for fine. Over here we have PSI, and then you have GPA at various speeds. So let's say you're going to do a rains and pasture weed control application at 10 gallons to the acre. If you had this XR8002 nozzle at 4 miles an hour, you would be emitting 10.4 GPA. You know, I find these tables are not exactly accurate, but they're pretty close. They're a really good starting place. This right here is a sprayer calibration app that Clemson put out a while back. I have it on my phone, and typically what I will do is I will use the table, get close, and then I'll use the app. So if you go through the app, you're entering the sprayer type, the nozzle spacing, the speed at which you can drive. Keep in mind, going over most of these pastures, we can only drive 3 to 5 miles an hour. In the row crop fields, they can drive a lot faster. But on pastures, it's hard to hold that consistent speed and maintain equipment in working order, especially if you have wild hogs on your place. It'll tell you how long you need to catch. And what this right here tells you is if your desired output is 20 GPA, you need to catch 254 mils in that 15 seconds. Okay, moving off of calibration, something else to consider is distribution pattern. Keep in mind that fine droplets offer better coverage, but that comes at a price of more drift. Okay, I'll just see a comment about losing voice. Is everything good? Okay, pizzas were good, so I'm going to keep going. Y'all can't throw anything at me today, but if anything happens, please somebody speak up. A boom sprayer will have more fine uniform droplets than a boomless nozzle. But keep in mind, if you're spraying weeds in the pastures, a boomless nozzle will become your best friend. This right there is something that I did a while back. And if you look at this, this is a boom sprayer at 10 GPA and fine droplets. And you can see that's extremely uniform, a very pretty spray pattern. We go to the next slide. Now we have a boomless nozzle at 20 GPA. What you see is some very large splotches, some uneven distribution, and a lot bigger droplet size. If we look at this one right here, we have these two 6-foot T-posts laying end to end. So you can see we're getting a very wide swath width, approximately 12 foot. But what I also want to bring you attention to is this area right out here. Not as uniform, not as consistent coverage. If you see this right here, that's very common of a boom type application. If we get up here, we have some more fine droplets. This is done with a boom buster nozzle. If you're spraying a golf course, this is not the nozzle of choice. But also if you're spraying a golf course, you'll have fewer fence lines, fewer trees to walk around. If you're going to be spraying a pasture, where you'll have brush, where you'll have fence lines and all of that stuff, a boomless nozzle is extremely convenient. Okay, moving back to the broadcast nozzles. You know, we typically see a lot of these little flat fans. That's an XR manufactured by T-Jet. You know, they work excellent for fine to medium droplets, 10 to 30 gallons to the acre. However, because of the fine to medium droplets, more drift potential. If we go over here, we have a T-Jet air inducted nozzle. If we look right there, we see that hole in it. That allows for that droplet to have a more coarse, bigger droplet size. Once again, we can still get that 10 to 30 GPA. So very convenient. If you have any sensitive crops and you're going to do a broadcast boom type application, I would highly encourage you to consider putting air inducted nozzles on your spray rig. Something else to keep in mind, the color of the nozzle impacts a lot about the size of the droplet. Every nozzle manufacturer uniformly color codes their nozzles. If we look at this right here, most of our range and pasture weed and brush control nozzles on this orange, yellow to blue stage. Fine to medium to coarse. Keep in mind, the smaller the droplet, the more drift potential. Also, if you look over here, you will see the micron size. We're going to look at microns more in depth here in a minute. Before we look at the micron, the droplet size, we need to look a little bit about drift. And if we understand some drift, that ties in very well with the microns droplet size. So all drift is the movement of herbicide outside the target area that occurs soon or at or after application. You know, in Texas, we are a very unique state in many ways. Being located right here in Stephenville, I am seeing vineyards pop up all over the place. Vineyards and grapes are extremely sensitive to rains and pastoral phenoxy, weed and brush control herbicides. We also have a lot of row crops such as cotton, soybeans, and if we go over around Comanche County, we may have watermelons, cantaloupes, and who knows what else. So, drift is drift, but however, there's a few various types of drift. We have vapor drift, the off-target movement of a gas, not a droplet. Lots of our old ester types of formulations of herbicides are very prone to vapor drift. Remedy, for example, is a ester type herbicide. You know, vapor drift is spray drift that occurs before the droplet has been deposited, and active ingredients significantly affect the vapor drift. Lots of these manufacturers are coming out with choline, coming out with amines, and they're moving away from the old ester formulations of herbicides. Okay, now to look at the microns more in depth. Just to give you an idea of how small it is, 1 inch divided by 25,400 is 1 micron. So the larger the number, the larger the droplet. Here's some examples for you. Look at a pencil lead, a paper clip, the human hair. A human hair is 100 microns. But keep in mind a toothbrush bristle, because lots of our applications take place at 300 to 400 microns. So a toothbrush to a staple, something like that. Something else to keep in mind, the droplet size versus the settling time. Look at that 400 micron droplet. Takes 2 seconds. The 80 micron droplet takes 40 seconds. With a little bit of wind, how far could that droplet go in those 40 seconds? So time to evaporate, to dryness, at 86 degrees Fahrenheit, at 50% humidity. Once again, a 50 micron droplet, which is too fine, nobody uses, is 4 seconds. 400 micron, which is more like what we would use, is 258 seconds. So all of that plays hand in hand. Here is something you really ought to keep in mind. Droplet drift versus wind speed when falling 10 feet. If we look at the 200 to 400 microns, because that's typically what we'd be using with rains and pasture, nobody would use any 50 or 100 micron sized droplets. With a 10-mile-an-hour wind, even with a very big droplet, we can still move 10 feet. Keep in mind, in Texas, when we're trying to spray, we often have a tough time finding days where the wind is less than 10 miles an hour. Something else to keep in mind when trying to calibrate a spray rig, when trying to get the pressure adjusted right, spray pressure versus spray volume. To double the spray volume, you must increase the pressure 4 times. This is not a good way to get your pressure to get the volume set. If you have spray volume problems, you need to look at slowing down or maybe speeding up, or you could also look at changing out nozzles. You know, for a higher spray flow, use a higher capacity nozzle, or as I just said, we could consider slowing down the application speed. And keep in mind to stay within the manufacturer's recommended operating pressure range, and ideally towards the lower end. Something else to keep in mind is that the spray volume does not directly affect the droplet size. Increasing the spray volume can effectively compensate for reduced coverage. But keep in mind, if you increase the spray volume too much, do you have enough herbicide in there to where you're calibrated to run that increased volume? Increasing the spray volume, though, it lowers the concentration of each active. So that's just what I was talking about. If you increase the volume too much, make sure you mix accordingly. Looking at the mortality and the impact that droplet size can have on mortality, this is some data done from a study we did down around McGregor. And if we look at this, we sprayed mesquites at various droplet sizes. Each one of these is the exact same herbicide, just at a different rate and also at a different droplet size. The recommended droplet size for mesquite management is 300 to 500 microns. If we look at the 400 microns at 3 GPA, we do okay, 75% control. If we come down here and say, okay, let's do a big droplet, 800 microns, at 10 GPA, our mortalities decrease substantially, down to right around 28%. Unacceptable job. What I suspect happens is if we get the droplet size too big, we're penetrating right through that canopy. Something else to keep in mind when we're outfitting our spray rigs, and these right here, they work good on an IPT, a spray wand, or on a boom type sprayer. If you put one of these little screens, check valve, it will prevent that nozzle from clogging. Maybe some of y'all clean out your spray tanks often enough, y'all do not have any trouble with it clogging up. However, I will clog up the screens very often, and I'll wipe off the screens and we're good to go again. Also, by using these little check valves, you will prohibit it from dripping whenever you cut off the pressure. Basically, that check valve only opens up whenever the pressure gets to a certain point, whatever that valve set for. Some IPT nozzles to consider. We have moved off broadcast now, and now we're talking about individual plant treatment. Anytime you're doing an individual plant treatment that contains remedy and diesel, spray in the base, this X1 nozzle would be the nozzle of choice. If you're doing an individual plant treatment, spraying wattle, spraying the leaves, a X8 nozzle would have a lot better coverage. Either one of these nozzles, it is convenient and to your benefit to put a check valve behind it that will prohibit it from dripping once you cut off, once you stop spraying. So that is much appreciated. Okay, now to the part on surfactants. Anytime I talk about surfactants, I always like to compare them to dribbling a basketball on a court. If you have that basketball aired up nice and tight, very little of the basketball comes into contact with that court. That is kind of like these droplets right here. If you deflate that basketball and you try to dribble it, it splats. A lot more of that surface area is covered with that basketball. So whenever we add a surfactant to a spray droplet, it basically takes a droplet and it deflates it. It moves it from this right here over to this. Flatten it out. The greater the coverage, the greater the surface area. This right here is a little comparison that I did one time, where I took a cc of a non-ionic surfactant and a methylated seed oil surfactant. For rains and pasture weed and brush control applications, the non-ionic is sufficient for 90% of the applications that we do. However, there are some applications that the methylated seed oil may give you a little bit of an advantage. So if you look, I deposited a cc of water, stays beaded up, and it doesn't move. Deposited a cc of non-ionic surfactant, and it spread out very nicely. And if we look at the MSO, it does have a little bit more spread into it. I need to redo this, and I need to put a cc of dish soap right there. Dish soap does not spread out and does not have the same properties of either one of these two. Dish soap also contains some active ingredients that could bind and tie up some of the actives in your herbicide. So I do not want to argue with success. I know there's a lot of people who have killed a lot of mesquite trees using dish soap. However, as a general rule, it is not as effective as some of our other surfactants. And also, if you look at the economics of it, surfactants are not that expensive. So if we do a few fast facts, kind of reviewing the two types of surfactants, a methylated seed oil is best for penetration of waxy leaves. Works well in hot and dry conditions. It's approximately 15 to 20 bucks a gallon. And if you compare the prices of a non-ionic and a MSO, they're about the same per gallon. However, if we look at the price per acre, and if we look at the usage rate, a MSO methylated seed oil will always be a little bit more expensive. Due to the non-ionic, the usage rate is 0.25. The methylated seed oil is 1%. Spray dye indicator. Works well if you're doing individual plant treatment. If you're spraying prickly pear, spraying mesquite, and you need to get each part of that plant covered, it works really well to put some blue dye in though. Lots of the tough grass guys use this as well to see the coverage that they get. One thing I will say is it is not a longer-term indicator. If you think I'm going to go spray mesquite this weekend, I may come back next weekend and pick up wherever I left off at. Good luck. You may need to wait until the plants you sprayed start to die before you see. The usage rates, typically 1/4 to 1/2%. However, keep in mind, you can play with those rates and get them to where you think you need them to be at. Some people complain they have a hard time seeing the spray dyes. There's very little other colors of dyes. I did run across a green dye one time. I questioned why any company would make a green dye to spray green plants, but it was out there. Some people have told me that the red dye exists, but blue dye is the most common. Something we need to look at is measuring herbicides. You know, lots of times people get this confused. And when we talk about IPT, that stands for individual plant treatment. Let's say the desired amount of herbicide is 1%. So 1% volume of the total volume. Let's take an example. We have 128 ounces per gallon. So 1% of that is very simple. 1.28 ounces of herbicide per gallon. 10-gallon sprayer at a 1% rate would use 12.8 ounces of herbicide if your desired target is 1%. For broadcast, a little bit different. What you need to keep in mind is how big is your tank and what is the gallons per acre that you want to cover out of that tank. We have some family land, and I have a little 65-gallon tank that will go in the back of a Kawasaki Mule that I have. I know with that 65-gallon tank, if I fill it up to 60 gallons, I can do 6 acres at 10 GPA. So keep in mind the ounces per acre. That's the amount of herbicide spread evenly over an acre. With lots of times with all liquid herbicides, we are doing 32 ounces a quart or 16 ounces a pint spread over an acre. With dry herbicides, lots of times we are looking at 1 ounces or maybe up to 3 ounces. Keep in mind the gallons per acre, that's the total mix. Herbicide, water, any surfactant sprayed over an entire acre evenly. Some steps to follow whenever you go to mix your herbicides. Put a small amount of water in that spray tank. Add the total amount of herbicide. This is where you need to know how many acres am I going to cover with that tank. Add any surfactants. Add any dyes. Fill the sprayer to the desired amount and go spray. Something that I often get questions about is If I'm going to spray prickly pear, or if I'm going to go do IPT, say mesquite, say prickly pear, why do I need to spray that plant so good? If an airplane flies over it, and you know an airplane cannot spray both sides of that prickly pear the same way that I would spray it by hand. Well, if we take an example, and let's say we're going to spray prickly pear. Let's say the product calls for 1%, so a 3-gallon mix would use 3.8 ounces of herbicide. Let's say a product calls for 32 ounces, a quart to the acre. A 3-gallon mix of that would use 4.85, nearly 5 ounces of herbicide. You get less coverage with broadcast, but if you look, we'll put in more herbicide, we'll spray in a higher concentration of that product. That is why we have less product going out. However, also keep in mind that individual plant treatment typically delivers a higher rate of mortality than ground broadcast. Also keep in mind that ground broadcast gives a higher level of mortality than aerial application. This right here is a handy extension publication that was put out a couple of years ago that fits in very well with lots of the other application technology information that we are talking about. If you look, you will see lots of our common range and pasture herbicides. You'll see if there's any grazing restrictions, any hay harvest restrictions, rainfast. How long do I have prior to a rainfall? Does it require a pesticide applicator's license? All of that stuff's very common information, handy to have. If you look up this right here, ESC 046, that's the number that you could find this publication by. With this next section, I was going to review some new developments in weed management. As I mentioned to begin with, range and pasture is oftentimes the low input crop. It does not drive a lot of new development like the corn, the cotton, the soybeans, those types of crops. However, within the next few years, we do have some new developments coming out. It's going to be an exciting time to be in this industry, I feel like. One of the newest ones coming will be Resilon. This right here is a herbicide that Bayer Crop Science is manufacturing. It's been released since 2010. It was released in the IVM, Industrial Vegetation Management, and the turf grass market. It's not active on perennial grasses, very, very low usage rates, and it's currently sold under these trade names, Esplanade, Allian, and Marengo. Keep those names in mind as we go through the next few slides. When it comes out in the range and pasture market, it's going to be known as Resilon. That's going to be the name of Indaziflan when it makes its way into the range and pasture weed and brush control market. One area where we have done a lot of testing is on annual ryegrass. And I realize annual ryegrass, lots of people have mixed feelings about. Some people love it, some people hate it. If you look at the slide, you'll see some benefits, you'll see some negatives. Lots of people who have it in their coastal fields, they say, well, if I can't beat the annual ryegrass, I may as well plant it and enjoy it. That way I can at least get some desirable, some cool season grazing. But then the downfall is, if left untreated, it can decrease the warm season Bermuda grass hay production. This is some annual ryegrass trials done back in 2017. We sprayed it in October for sick annual ryegrass control at 7 months after treatment. You can see we put it out at 3 ounces, 3 ounces applied twice, 5 ounces and 7 ounces. We compared it to Prowl. Prowl H2O is currently the gold standard. There was no comparison. Esplanade, Indazoflan, Resilon, whatever name you call it by, has a lot greater performance on the Prowl H2O. There were some pixels. These plots were sprayed over at Ellis County, Texas. You can see this right here. This is warm season grass germinating. Over here is the annual ryegrass finishing out its life cycle. Crabgrass. This is a common warm season annual grass. This trial was sprayed in March. Keep in mind this is a cool season product. Did Esplanade at 3, 5. Compared it to Prowl. We also did Esplanade 3 ounces, followed by 3 ounces after the first cut in the hay, 5 ounces followed by 3, and then we did a Prowl. If you look at our data, I do not think you see enough increase in control to justify that additional application. However, that is for you to decide. Oh, excuse me, I was skipping over the big one, Sanibel. This right here was a timing trial we did. This took place down at Robertson County. We did 3 treatments in December, 3 treatments in January, and 3 in February. Then we did 2 pastoral treatments in April. What we did 3 ounces, 5 ounces, and Prowl. Then in January, we did the same thing. We added in Roundup, and we added in Cimarron Plus to get some control of some of the cool season weeds. You see, we got some really good control with this 5-ounce rate. You also see that we had some areas where Prowl looked pretty good. But talking to people throughout the state, it's very inconsistent. So that's all the information I have on that product, that Indazoflan. I'm excited to see it come into the Rains and Pasture market, because I feel like it will offer a lot of advantages for pre-emergent weed and brush control. And I see we have a question. Is Indazoflan a pre-emergent? Yes, it is. And only pre-emergent that can be used in pasture. Or no, the question is it the only pre that can be used in pastures? Currently, Prowl H2O is labeled for use in pastures. When Indazoflan gets that label and when it comes out, it will be one of 2 pre-emergents. That is what I'm excited about, some more options for these guys. I see it having a big fit on the high-end hay market. Those that try to grow equine quality hay, I see those guys being the ones willing to spend the money to control crabgrass, ryegrass, and so on. I hope that answers your question, Hennon. The next product that I was going to talk about was Duracor. This is a new active ingredient from Corteva, which is the old Dow AgroSciences company. This right here was applied via dry fertilizer. Looks really good. If we look at this right here, this is a Duracor on snow on the mountain and on the broomweed. If you look at this right here, we see the rates. 16 ounces to the acre, and this was a MSO study where we looked at rates, comparing it at various MSOs. If we look at some of the application methods, we can still do the conventional foliar application, no problem. If you're mixing it with a liquid fertilizer, it does extremely well. However, you're also still able to mix it with dry fertilizer, no problem. Does well with that too. So if you have any of those deals you've currently been doing with your broadleaf weed control application, you can continue doing all three of those methods with the new Duracor herbicide. The usage rates. We started out talking about calibration. This right here is kind of the evolution of some of Dow's common go-to broadleaf weed control products. Grazon P plus D, 32 to 48 ounces. Grazon Next was 24 ounces. Now look at this new one, 12 to 24 ounces. As usage rates continue to decrease, calibration becomes even more important. Some other benefits of this new product: non-retracted, less tank mixing, low odor, non-volatile. We talked about drift today. That's extremely important, as well as no 2,4-D or dicamba. In some of those retracted counties, that becomes a concern. Also, with some of the 2,4-D and dicamba tolerant crops these days, these two actives have received a lot of bad publicity. Something else to close up on today, since we are nearly out of time. For weed and brush control, or for weed control, keep in mind, spraying is always cheaper than mowing. If you have a 40 horsepower tractor with a 6-foot mower, it would cost you right around $16 an acre. With a 40 horsepower tractor with a 30-foot boom, it's $12 an acre. I disagree with these numbers. Nobody can control weeds by mowing it one at a time for the entire year. Also keep in mind, anytime you mow a pasture, how much forage production, how much grass you are losing for that year. With that is all the information that I had. I thought I had my email address right there. I will put my email address there in the chat box. And if anybody has any questions, feel free to ask. I'll stay on for a little bit.
Thank you, sir. Very good. Yes, if y'all have any questions, y'all feel free to type in the chat pod. And again, let me go ahead and then mention one more time that this particular course has a 1 CU IPM. Due to the holidays, everything else, I didn't quite get the registration form ready where you can click to go pay for your $10 for your CU credit. I will put it up at the Texas Range Webinar.tamu.edu where you can go pay. If you watched it today and you want CU credit, go and type in your email address and it says, I know that you watched it because I'm recording the login, the people that watched it and recording your email. We'll compare that to the pave roster, and we'll send you we'll email you a certificate. Again, while y'all typing out questions, let me say that February the 6th will be our next February 6th, 2020 will be our next webinar. And you can visit us at texasrangewebinar.tamu.edu. If you're not doing so, you can follow us on facebook.com txrange. And come February the 6th, we have our webinar is going to be Beyond the Bob White, Managed for Bird Diversity on Rangelands. And Dr. Maureen Frank is going to be our speaker. So look for us on February 6th and look for us as well on email. Any questions for Mr. Jackson or for me? Feel free to type them out on the chat pod. I'm gonna go ahead and pop out a web link. It should be your survey. If it covers up your screen, just look down the bottom of your screen. You see a little green looking icon. You click on it, you can get back to Adobe um, Connect.
Alrighty, well, Pete, if nobody has any questions, I'm gonna log off. Thank you all for joining today, and I appreciate that.
Thank you, Mr. Jackson. Very good. I appreciate it. And have a great rest of the week.